here. It's like Michael Schmidt and Eric Finot. Welcome, folks. Guess who won the pony? Good morning, everybody. On this fine Thursday morning here in San Francisco. I hope that you are having a great morning or evening or afternoon, wherever you may be. Please let us know where you're joining us from when you join in the chat. We like to see where our global community is tuning in from every single Thursday. I, of course, coming to you from beautiful, fragrant Soma in downtown San Francisco, California. Satya, where are you joining us from today?
As always, from San Diego, California. It's not the usual sunny here. It's one of those, 60 days or maybe 30 days in the year when things are not perfect.
Yeesh, man, what are you going to do? What are you going to do with yourself?
Terrible,
Where are you joining us from, guests? Vahan, start.
Yeah, so I'm joining from Armenia. It's like eastern part of Europe.
Yeah. Oscar, where are you joining us from?
Lovely evening, as you can see.
Yeah.
I'm joining you from Stockholm, Sweden. So it's going to be a nice evening today with this webinar. Looking forward to it.
Sweet. Yeah, international flavor here on OpenCV Weekly Webinar. All right. Good morning, Nigeria. Good morning, Belgium. Blowing up over on LinkedIn and YouTube. Good morning, Bangalore. Good morning, Denmark. Good morning, United Arab Emirates. Good morning, South Africa. Good morning, Serbia. Hello, Iran. Christopher on LinkedIn says, I moved my Marshall stack. No, I did not. I moved my camera. It's a baby stack. It's their very cute 1 watt Marshall amp with a big ass speaker cabinet. But I love that thing. Totally worth it, by the way. If anyone out there looking on those the lower power Marshall heads, they are really good. And very affordable. Good morning, Canada. 2 Canadians. Hey, Canada. We love Canada. Good morning, DRC. Hello, Milan. Hello, Italy. Hello, Portugal. Hello, Turkey. Yes, hello, another South Africa. And hello again to Dan from Picayune. We will get started in just a few minutes here. Good morning, Saudi Arabia. Hello, India again. Hello, Mexico. Hello, Senegal. Hey, Steve. It's good to see you last week as well. I got to meet Steve in person at the Embedded Vision Summit. That was cool. Got to say good day in person. Little upset you didn't bring me any Timbits, but there's always next time. Good morning, Brazil. Give it another few seconds here, and I think we can probably get started. Hello to the 7 of you watching on YouTube. Let's get a quick numbers check on LinkedIn. Hello to 73 of you on LinkedIn this morning. We appreciate it. Good evening, Singapore, where it is midnight. It's always midnight somewhere, I suppose, especially in my heart. All right, I think we're about ready to get going. You ready, Satya?
All right, yeah. All right, let's get started. Welcome, everybody. Welcome to OpenCV Weekly Webinar. I'm Satya Malik, the CEO of OpenCV. And today we are going to have a very interesting episode. As you know, the segment anything model, also known as SAM, is taking the computer vision world by storm. It is being integrated into several tools, including our own segmentation tool, computer vision annotation tool, which is at cvat.ai. And today we have with us the CEO and solutions engineering lead of SuperAnnotate, which is a very good annotation tool. And they have implemented SAM in their own pipeline with unique twists. So please welcome Vahan Petrosian and Oscar Ornberg to the show. And but before we go there, we also want to welcome Phil Nelson, who is the Director of Content and Creative at OpenCV, and he produces this show. If anything goes wrong, it is his fault.
Yes, that's absolutely right, Satya. I'd like to start the show off by wishing everyone a very happy and very gay Pride Month to all who observe. I am your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. It's Mr. Nelson if you're nasty, but you can call me Phil, and I'm here to remind you of a few things we do every episode of this show, the first of which is a giveaway to you. In the audience, our generous guests have told me that they will give 1 year of SuperAnnotate to our trivia winner later in the episode and 50,000 upload credits. Thanks so much for that, fellas. So stay tuned later. You'll get the chance to answer a trivia question, and one lucky winner will get that sweet SuperAnnotate deal. We're also taking questions from you in the audience, and we will answer them, as Mr. Iwata would say, directly. So please put those questions in the Zoom Q&A button or the chat system wherever you're watching, YouTube, Twitch, Twitter, Facebook, etc., and we will do our absolute best to flow them into conversation as we can, also saving some time at the end of the episode to answer those questions we didn't get to during the show. Back to you, Satya.
All right, Vahan and Oscar, welcome back. SuperAnnotate has been on this show a couple of times before, and it's always a pleasure to see how these annotation tools are getting so much better over the years. So let us know what's new in SuperAnnotate. Welcome back.
Thank you, Satya, and thank you, Phil. Yeah, thank you all for having us here. I'm really excited to talk a bit more today about what we have and cover more about segmentation in general. So yeah, looking forward to it.
All right, it's your show. Take it from here.
Evan, you're on mute if you want to share something as well.
Oh, perfect. I didn't realize that, but can you see my screen now?
Looks good.
Perfect. So Oscar, please take the floor, and then
I'll take it away. Yeah, we're going to present a little bit, as Satya said, about segment anything, the implementation we have about it in SuperAnnotate, and talk in general about segmentation and the segmentation task. We're already presented, but my name is Oscar. We have Vahan here. We're going to be happy to cover this and talk to you all today. So feel free to ask any questions as well. We're more than happy to answer that. So what will we talk about today? Well, when I first kind of lay the groundwork a little bit regarding segmentation tasks, I think most people here are quite familiar with it, but just to have a same baseline for everyone. Then we can go into a couple of use cases. Just want to showcase how, what we see at SuperAnnotate, some different use cases out there for segmentation. You can also see some tips and tricks on how to leverage this. Of course, cover the segment anything model, how it works, and demo what it looks like in our tool. And then I'm going to wrap up and answer all of your questions out there. But segmentation tasks, that's the first one. So how do we think about this? Generally, we try to separate it into 3 different areas. We have instance segmentation, semantic segmentation, and panoptic segmentation. So the instance segmentation tasks that we see would generally be a differentiation between the instances that we see, but we're not really covering every pixel in the images, so to say. So a lot of common data sets like Coco, for example, cover this out there, and a lot of models leveraging this as well, like Mascarsin and other things. When we go over more to semantic segmentation, we're not really doing any distinction between the different instances of the same class. We're just kind of segmenting everything out, and we're segmenting every pixel in the image. We're quite common as well, cityscapes, datasets, and others out there. And when we go a little bit more in depth, we come to the panoptic side, which is sort of a combination of both. We are doing a distinction between the different instances of the same class, but also segmenting everything. At SuperAnnotate, we see this like sometimes, but it's absolutely not as common as the others. But it would be really interesting to hear like what kind of use cases people have and if people are leveraging any of these more commonly than others out there.
Yeah.
But those are kind of like the baseline, and these can be applied in a lot of different use cases out there as well. So some of the things that we see in terms of different use cases in kind of fantasy sets the limit. But
Oscar, can we go back to the last slide? I just want to clarify one thing for the audience. So some people may be thinking that, oh, panoptic segmentation is the best among the 3 because it covers everything. Why not just do panoptic segmentation? Why even bother with semantic segmentation or instance segmentation? And the reason is that it is more expensive usually. In fact, semantic segmentation is the cheapest one here. And after that, if you want to do instance segmentation, it is usually computationally more expensive. And then we have panoptic segmentation, which is more expensive even than that. So that's the reason we have these three different modes. And one other example where you could use semantic segmentation, let's say you want to have, you want to segment cars. Let's say you have, you want to segment car in a photo and you know for sure that there is only one car, or maybe you want to segment a person in a video and you know that there is only one person, then you can use semantic segmentation for that because you know that there is only one person, or sometimes you don't care how many people are there. You just want to remove the people or the car or do something with them, and you don't care about the identity of the person. In that case, you could use the cheaper semantic segmentation, while but if you care about the identity, then you use instant segmentation.
Yeah, I think you're really good points for sure. I mean, it's really up to the use cases that you see over there. So good point to it. And lots of models out there, and yeah, everything is kind of growing all of the time. So things are changing. We'll dive into more like what SAM does in relation to these as well.
Yeah.
But they can be used in many. So like the first use case I had in mind was kind of like a defect detection use case that we see quite often in, say, infrastructure inspection, manufacturing, and we can see here like semantic or instance, for example, but semantic can be quite common. And there are some intricacies with the different use cases that are not necessarily based on the type of models, but more on the use case itself. So when we have defect detection, it can usually be very small objects we're trying to find, with also potentially blurry borders. It might not always be easy to accurately define where the object starts and ends, or the area itself. And to do that, you might need some kind of expertise to really be able to outline these as well. So you might need people that have been in analyzing these concrete things their life, or know the assembly line that we're working on to really find these defects. And going like very far away from this, just doing an object detection use case to do a bounding box here, that's just going to be like too much noise, and you really want to understand the area of these objects as well. So you're not really want to do that, but you want to do segmentation. And can also be similar for other cases.
So one thing that I remember from our customers, I remember there was a use case where we had like 80 different types of defects. And this is becoming really tough because identifying a defect sometimes is very easy, but then classifying the defect is becoming like you need very long like handbook to find which defect does this resembles to. And then those defects can be in different objects. So sometimes it is really a pain to annotate in general.
Right.
Exactly. Yeah, and that is very true. And that's basically the same for these other, just the general, either semantic or instance segmentation of different objects. That can also be a huge problem in like e-commerce or retail, because just classifying things like hat, hair, or gloves, sort of understandable. But when you go into, say, a retail use case, it might be millions of products in a store, and all of them have to be uniquely identified, which is becoming not only difficult because you have so many classes you need to classify in, but also just labeling this data becomes really hard. So you have a lot of objects in the same image, perhaps you have a lot of classes, could be also attributes, the clothes here, not only is it a hat, it might be a felt hat or a stylish hat or something like that. So it's not always that easy. It can be a lot of levels here in terms of classifications, and models then can be used. And they might also overlap quite a lot on top of each other, making it, are we going to go with like just one mask for the whole image, or do we need to have, say, one mask per object in one way? And same thing here, like we don't want to go object detection, just too much noise. You're not going to be able to capture all of it. Think about it as you have a tie and you have a bounding box around it, but you have the exact same bounding box around the shirt. You're not going to be able to discern too much of these areas as well. So now we have like some use cases leveraging perhaps that's more normal, say phone cameras or something, but there are also a lot of others in sort of, say, area segmentation from remote sensing and similar in forestry, agriculture, infrastructure, or insurance. Like you want some area of objects, whether it's forest, roads, houses, and so on. And here you might also have like extremely high resolution images, making it even harder to just just visualizing all of it. Same thing here, and it can also be very hard to define the borders. It can be quite blurry, and looking at even high resolution cameras from space can be like 3 meters or more in width for like 1 pixel. And if you're going to define the edge of a road, your plus minus 3 meters can make it quite blurry to define exactly where the border is. So looking at pixel accurate segmentation can be a bit difficult to actually go through sometimes, because what is accuracy at that level? So a lot of these scenarios we also see a lot of autonomous vehicles, but like that's not only cars, right? It can also be boats, robots, drones, these other things. And usually about some kind of drivable area, right? Like where can a vehicle operate? Is it in the ocean? Well, then that's the sea. Is it on a car? No, it's the road. Trying to identify these areas and really segment them out is going to be important. And you can't really do that with anything else but segmentation, right? And a key problem or a key thing to think about in these use cases is that you have this kind of point of view that you get. So you have objects that might be very, very far away. So I think it's usually good to think about how you're going to deal with them, because you're going to have objects far away that are going to be hard to discern for a camera, for example. So you might want to have another type of class for objects far away, more like an object class or some kind of group of people or vehicles, because it's going to be hard to discern from a human standpoint and a model standpoint at that sense. And that kind of goes into the definition of accuracy for you. Like it's important for you to define, because the level of accuracy needed for models, I mean, Van will talk about that a bit more later, but that is also debatable in academia as well. The main thing is that on our case with the labeling, it's going to be a huge difference depending on how accurate you want something. This is just one part here, but think about just in Zoom here, if you're going to label every strand of hair, that might be extremely more time consuming than just doing a rough shape around it. So having that definition is going to be critically important. So I can have a lot of use cases, right? But how do we actually do these annotations in the end?
Yeah, so I'll jump in here. Basically, in general, when we're thinking about annotations, we have really 3 different like large classes of annotations. Those are like manual annotations, AI-assisted annotations, which are like also called interactive segmentation. And then there is this model-assisted annotations as well. So depending from the application, it really defines the way you can generally do, or you can kind of mix and match, but sometimes you really need like the manual touch. And those are the cases with one of the applications. Oscar said if you really need to kind of predict the hair very, very accurately, then most of these AI-assisted annotations can kind of catch the hair shape, but then all these different like teeny tiny details, you need to edit those masks. And sometimes when you're looking at like what's good or bad, then manual placement really allows you to kind of be very, very exact what you're doing, but that comes with the time. And that's basically the trade-off between generally those 3. When you're thinking about the AI-assisted annotations, then you can say that the placement is done by some type of general model. It is interactive. It can be by text input. It can be by a point. It can be by making like a pen scribble. It can be based on the box where you will predict whatever is inside the mask and so on. And here, more or less, you can use those to speed up your annotations, but sometimes it's coming with limitations, because not all the objects are perfectly selectable, and then going to manual or not, it's really up to you based on your requirements. Then the model assisted is when you're trying to evaluate your model, you kind of dump all the annotations into just using the model, and then you kind of correct and check whether something is annotated correctly, so there is less interaction in here. And for here, you need model to be trained. So this is oftentimes is a bottleneck from the beginning, but as you're doing more model in the loop, then this is becoming faster and more accurate to annotate as we have better and better models.
Right. And the difference, I mean, just so people, I also want to clarify, is the difference between AI assisted and model assisted is that the AI assisted tools, they may not know what you're segmenting, right? The AI assistants, for example, the same tool would help you better segment cars and people, etc. It doesn't have a notion of what the underlying object is, right? But model assisted, and correct me if I'm wrong, Vahan, is it actually is based on the model you're already training. Let's say you had a people and vehicle detector, and you want more data for that model. In that case, you would run with an existing model, which may not be very good, but with the existing model, you run the picture, pass it through that model, and you get the results. And it would do something. It would give some annotation of the car and the person, and then you go and manually fix it. So that is model assisted. Is that the right description?
Mm-hmm. Yeah, absolutely. And then when it comes to segment anything, more or less we're thinking on this AI assisted approach because it's an unsupervised or self-supervised learning approach. It was trained with very, very large set of annotations, but at the same time, people didn't really say that this is a car, this is an object A, it's object B, and so on.
Yeah.
So we have a very nice article in our blog post where we discuss different ways of doing AI-assisted labeling. I mentioned it earlier. So there is this scribble-based, superpixel-based, point-based, and so on. And here we put a lot of advantages and disadvantages, and also wrote down what is better suited for instance segmentation and semantic segmentation tasks. So strongly recommend to read this blog post in general. And then let's talk a little bit about this trade-off between the accuracy and the runtime. For the annotation side, because human annotations can be very, very expensive. So I want to point out this CVPR paper that came out in 2018, I think, which seems like forever now. And the researchers from MIT did a very interesting experiment where they took and then they did very fine annotations. And then they went to one level coarse annotations. So where they miss 4 pixels and then 8 pixels, 16 pixels, and 32 pixels. Since you're doing this type of annotations, then the annotation time is becoming faster and faster when we're thinking in terms of human labeling. But if you're using AI-assisted annotations, it can be a similar type of effect, right? So what this plot is concluding on the right side is that if you really want to use pixel perfect accurate annotations, then you're getting this type of plot where your mean IOU score is increasing when you're doing more and more labeling, but when you're doing more and more labeling, then you spend more time, and this costs a lot of money in terms of human labeling, and it's also quite a tedious job. But all these other experiments are showing when you're kind of mixing and matching, mixing the very fine annotations with some type of coarse annotations that you've done, then you're getting very much reasonable, or even slightly more in this case, better mean IOU. And what this really means is that instead of spending more than 100 days on the human labeling, you can mix it with less accurate annotations, which can be done by your AI-assisted labeling and so on. And you will still be able to reach that accuracy as far as you have slight amount of very, very fine annotations.
Right. And the x-axis here is in log scale, right?
Correct. Yeah.
Okay.
So this is
it's much worse than what you're looking at. One is 100 days and the other is, maybe much less.
So this is probably 30 days, and then this is 200. So maybe it's like a 10x type of difference in here. Yeah. So so the learnings from here is that when you're trying to get something done with the labeling, don't really always think that everything has to be perfect. You can kind of define this percentage and then mix sometimes with potentially AI-assisted labeling that will be accurate, but not really like pixel perfect. And then you can mix that with manual labeling that can come to that. And by saying this, I want to pass it to Oscar.
Yeah, exactly. And I think sort of as we talked about here, we have the AI assisted or model type labeling as well. And segment anything, we read the paper and recommend people who haven't done it to kind of take a look at their blog and see what it's all about. It's very interesting in sort of taking ideas more from NLP foundational models and bringing it to computer vision and segmentation instead. So we are kind of converting the NLP prompt to a segmentation task instead. Normal type of prompts we might be used to in terms of ChatGPT and so on is by writing a natural language message and getting a response back. Now it's about putting in some kind of prompt or input, which could be like a point, a bounding box, a rough segmentation, free text, something that's like the input we are giving to the image. And we're getting a good segmentation mask out instead. That's kind of the answer in this analogy. And that's also, I think, like sort of the difference here, like AI assisted or model assisted in that sense. Model assisted is just you feed in the whole data, right? You get the image in, you get all of the answers back. In these scenarios, you have to give some prompt in, where that is like a point on the image, a bounding box or something, but we are specifying some kind of help to the model, to AI systems in giving a more finer answer back. And the case here as well, which is kind of interesting, that differentiate this from some other tasks as well, is that the answers, like the segmentation mask, is as in NLP a like non-objective. It can be a subjective answer. We don't necessarily know just based on one point what is the right segmentation mask. We can see here, like, I think it's an emu or something. There are different regions that could be a possible good segmentation mask that is coming out of that prompt, or with the backpack, for example. So we don't really know exactly what is the right answer, so we need to be able to generate and work with it from that setup. So that's kind of the baseline from where the research started, and they wanted to create more of a universal segmentation model. So what they did is create first an image encoder, and that's like a normal visual transformer model that they ran to create the image embeddings so we can work with it instead. And these they can be pre-computed, so it can save up time, because that's usually otherwise a time-consuming effort to do, right? The other is more of the prompt encoding, because we can have multiple different inputs, whether they are points, bounding boxes, or so on. We need to be able to encode them to the same thing. And we're merging all of this and having a kind of lightweight decoder to generate out a couple of different masks. So we have a good image encoder, we encode the prompts, and then we decode all of it to a couple of different potential outputs that can have a confidence score of which one we think is the best. But as we will see, we'll be able to kind of switch between these as well, so we as the human can make that decision as well. So this is what they used to create this, and they trained it in like an iterative fashion to improve it more and more and more and more, make it better. And when they did that, they also created the data set that they released with it. So not only did they release the model itself, but also I would say the largest segmentation data set out there, like 11 million images, 1 billion masks, and that's from this kind of interactive model-assisted labeling setup. So they mentioned that they improved the labeling speed from like 34 seconds per image down to 14. And even 14 was like, 6.5 times faster than the mask annotation for the COCO dataset. And that one has classes though, so might be part of it. And they went in a sort of iterative fashion to create this model. So first it was mainly just manual annotation. And then they went into this semi-automated setup where they could actually speed up the annotation quite a lot by leveraging the existing model to help speed up the labeling itself. And in the end, they just fully automated like all of it really, and just generated out a lot of masks, processed a little bit, but generated out the rest fully automatically. And that is actually the only things that are available in the open source dataset is automatically generated masks. And the images were initially kind of high resolution, so they're taken from professional photographers all over the world, downsampled a bit to some more reasonable or manageable size. And from these, I think 1 billion masks, like 99.1% were generated fully automatically. These 0.9% were used to train their model, and those specifically are not released out to the public. And as we talked about previously, like there are no classes in this, it's just generic objects. So it wouldn't work out of the box as a good model unless you only have one class, really. They also, I think we can talk about the improvements being made. They made some kind of like responsibility analysis of this as well. And it's kind of a geographically diverse data set and fair in different segmentations of age, sex, and so on.
Yeah, I just didn't realize that you didn't cover that last part, Oscar, so I was going back and forth. But let's talk a little bit about the improvements. If there is any comments, Satya, would be happy to hear. Otherwise, we will jump to the improvements and the demo on our end.
Yeah, I just want to make a comment. I should have made this comment before, but for beginners who might be, a little bit confused about how these different tasks in computer vision tie together, I just wanted to set up this thing, how it starts with image classification. Now, in image classification, you have an entire image, and for that, we output a single label. So the input is an image, and the output is a single label which describes the image, and that could be cat, dog, etc., right? But as soon as you have multiple objects in the scene, you need something like object detection, where you want to put a bounding box around the object that you want, and you need a label for every bounding box in the image. So now you have become more granular, right? You started with image classification, which was very rough, right? Then you went to object detection, which is finer than image classification, because now you have multiple bounding boxes and every bounding box has a label to it. And then you go to segmentation, where instead of bounding boxes, every pixel has a label to it, right? Every pixel, you say that, okay, this is a cat or a dog. So that is semantic segmentation. So gradually we are going higher and higher, granularity is increasing. And you can go even further than segmentation, where instead of saying that one pixel belongs to only one class, you could say that it belongs to a mixture of two classes. And that is usually alpha matting. And that is useful when you want to segment out hair, for example. So the boundary of the hair is not completely one particular class, right? It could be the hair class and the background class. So you can move one further step in granularity, and that is called alpha matting. So I just wanted to do this before we started the conversation about segmentation, but this is as good as a time as any other. I just wanted to set up that.
That's perfect. Yeah. So that was like a really small and history of computer vision development, especially from 2012 up until now.
Yeah, that was like a mini course right there.
Yeah, exactly. So yeah, let's jump to a demo on our end, right? So I will switch the tab, and then we'll come to create this project from Segment Anything. This is the pictures, same pictures that Facebook AI research is using. So let's say if I'm gonna open one of those images in our platform. So you can see that we have all the tools on our end on the left side. We have all the images on the bottom, and then we have some annotation objects that we didn't really put on the right side. So when it comes to the manual tooling, as we were discussing, so we have all these different types of manual tooling, including the polygon annotations. If you're trying to, I don't know, select some of these strawberries, some of the strawberries, you can kind of go it like by points one by one. You can scribble it if you want to, and then that will be a little bit faster, but not really that accurate. So maybe this is part of that trade-off as well, to annotate the strawberries, for example. But
it is a very fancy breakfast. I wish I had time for that.
yeah. So it's deliberate. So you will open your appetite, and after this webinar.
Yeah.
So let's see, we have this magic select on our end, which is the new tool that we built, which is using that backbone of segment anything, where it is allowing you to select different objects and changing the layers, which we'll cover soon. So here, the model is running on our side, and then when it's running, then we're not really showing you anything, but when you're hovering, one of the quick fixes that we did is like, we fixed very much the latency, because as you can see, I'm hovering here and there. There is a very, very quick change in showing the objects and the segments and so on.
And so this is all live. We are not looking at a video. This is you doing it live, right?
Correct. So this is all live. So let's say I want to select all of these bananas. So it's going to be 1, 2, 3, 4, 5, 6. And then here you can see that it's selecting 2 bananas and didn't really catch all of them. So what we have on our end, you can quickly switch to our magic polygon tool, scribble it. And then this will be that scribble-based approach where you will be able to select other objects if it's not really catching, right? So let me come to the magic select. Here you can see it's not catching, but if it's not catching, I can quickly switch, and then I can select on those things, and it will be able to catch those things very, very quickly.
Quick shout out to the great Harry Belafonte. We are, as we tally some bananas here.
Nice, yeah. So the other small point that we added in the segment anything, sometimes when you're trying to select an object, the object can be in the background, and then it's not really easy to know kind of how to select that. Sometimes you can go to a next place, and then that will be able to give you, but imagine if you will have another object in here, it will be hard to kind of get that object in behind. So what we did is we created a simple shortcut that when you select that shortcut, it's kind of changing the layers. And then when it's changing the layers, so once you find your correct layer, then you can click on it, and that will create an annotation on our end. So that's gonna become very simple. For example, here you can see that if I want the entire thing, then I can again change the layers and pick those. And then all of this is very, very, we solve all the latency issues, and that's becoming very, very smooth, because if you have annotators generally complain about those small milliseconds that are coming to play. I'll jump out from our editor, and then we'll cover a little bit around, once you did the annotations, how you can quickly do a quality check, and then maybe correct some of the annotations, which is more or less, it's covered in our Explore tab. So let me go to this, I think it's this fashion data set. And let's say I use segment anything, quickly annotated several thousands of images, and now I can come to the Explore tab in our platform. And what you can see here is different type of images, the annotations on top of them. And sometimes it is not really enough to look at the image, because I'm particularly interested, let's say, in shoes, and then there is not really enough information to look at the shoes. I can change the layers, number of columns, but even in this case, it's not gonna be enough. So what you will be able to do here is like, you will change to this instance mode. And we're zooming into each and every object, and which is really allowing you to kind of see each polygon, in this case, one by one, and say, is it good or bad? So, but as I said, I'm only interested in shoes. And if I want to do a very quick quality check of shoes, then I will select shoes and apply that filter. And now I will say that I need 4 different columns for this. And let's.
Is it from the same pictures that we were looking at just a few seconds before? It's
Yes.
zooming into the shoes.
Correct.
That's very
Exactly.
cool. Yeah.
And now you can see that here sometimes people annotated two different shoes together. Sometimes I already can see a mismatch in my annotation instructions, right? Because here it is a really quick way of seeing whether everything is consistent, because instructions is probably more important, and following that correct annotations is going to be a key for you to build a very accurate segmentation model. And then if I see those ones are okay, but then sometimes here it's the same mistake. If I go down, maybe we'll be able to catch more mistakes, right? So there we go. So here we can see I have a shoe where some people are extracting the areas from the shoe. And then sometimes they're not really extracting the areas. Sometimes they even have one shoe that is in two different polygons. They're not really grouping them together even. So basically, bottom line, what I'm saying in here is like your annotation instructions are going to be really much the key for getting a highly accurate segmentation model. And sometimes when you're missing here and there a few pixels, then that might not be that relevant, rather than when you're doing this type of heavy mistakes in your annotations, which is the non-consistency type of object selection. And then oftentimes we can come to the Insights tab, which Insights here is allowing you to get any type of statistics on your data set that you have. So now on the left side, we show you can measure anything you want. Let's say we're measuring the counts, but and then we're breaking down by the status of that item. So you can see that most of our images are not started. But if I want to check something on my polygons, then I can see that shoe annotations is, I have 126 shoes, but I have a very long tail, which is a big problem in computer vision, as most of you know. And this type of things are helping you to kind of understand what is it that you're looking at. So let's say I'm going to change the count to number of polygon points, and here immediately I can see that the code, for example, has a lot more polygon points. So if I'm assigning that to annotators, maybe it will take a lot longer time to annotate those things, versus if I have something like belt, then belt is generally less. Oh, I think I did a mistake, Oscar. So instead of taking the sum, I need to take the average number of polygon points. And this makes a lot more sense, because on average, there is 173 points on jeans. But then if you're looking at the ring annotation, then there is a lot less polygon points. So it kind of gives you the complexity of your polygons that you're creating and so on. Yeah, and here more or less we can do a lot deeper dive, but I'll stop presenting in here, and we'll pass it. Oh no, I think I need to still share the screen, and then let's see.
I mean, I think this kind of covers a lot of the things that we have talked about and kind of everything that we wanted to present, really. This is like a way for us to see, you know, these models are interesting to start leveraging to see how they can help in your work, whether they are to be applied directly or just to gather a data set to train another model that might fit better in the specific use case that you have, if it's on the edge or something else out there, right? So yeah, that's about it. We're able to hear what people have to say, and if there's any questions.
I have two ideas for people who are developing segmentation tools. And I don't know how good the ideas are, but I'll just throw it out there. The first thing is that, you know, in interactive segmentation right now, the mode is that you either have a bounding box, you have a point, you have scribbles, right? So these are the kinds of things we do, which is fine, which is great. Will it also help if you have a prompt, right? Where you say a text-based prompt, where you say that, oh, this thing that I'm trying to segment is a car, right? And then maybe you have a better segmentation because maybe the SAM understands that, right? Or you already have a trained model which you can use to create a better segmentation, right? So does adding text in addition to all the clicks, scribbles, and bounding boxes improve the quality of segmentation, right? So that is something maybe somebody would explore. And the second idea is I'm very excited about this idea. Generative AI, right? Right now, you can type in pretty much anything and it will generate an image for you, right? So you could say that a picture of a person standing in front of a car in such and such background, right? And it will generate the exact picture for you. But now, because we have this additional, we have this big data set, right? SAM data set, you could actually combine the two things, saying that, okay, I'm going to train a stable diffusion model where it is not just going to output the image, it is also going to output the segmentation, right? And that way you suddenly have everything that you produce synthetically comes with the segmentation, right? Because you have such a big data set available through Facebook, the SAM model.
There's actually been a lot of interesting examples just regarding that last thought, when like not really using SAM, but just concatenating two images like mask and normal image, and then generating more, which is like say a really interesting topic to make it like synthetic data in that sense.
Right.
Yeah,
Super interesting.
Absolutely agree. And it's kind of a fancy way of doing data augmentation, right? Because once you find your edge cases, you want to create a similar edge cases like that. On that end, actually, if I will be able to very, very quickly kind of come back to what we're doing in here, it's like if I see that this is an edge case on my end, what I can do in here is like I can select that, and then we have this generative AI approach that is allowing you to create similar objects, right? So here we're saying like, okay, you can pick your prop, and then I want this upper part of the body with the taxi car and so on. And then I can submit this as the image that I want to create similar images on our side.
Right.
And this kind of go and run some of the generative AI models on our end, and then kind of create 6 different images that are similar to this. So you can see that it didn't really produce the faces that well. The faces and hands, we know that there is generally a problem.
This poor woman's being mauled by a lemur or something.
Yeah. It's so, and then what you can do, you can also have a text prompt and generate more images like this, and then you can collect all this data set and then send it back to the annotation. And, especially with those edge cases, it can be very, very interesting thing to do.
That's great. And at OpenCV.ai, we're also coming up with a new product called Copycat, which I don't know whether you have seen that. Anna must have shown it to you, which basically creates many variations of the same image. The segmentation remains same, but you create many variations of the same image. And in case of pose, you can also move the camera angle, and it creates new poses from the camera, from different camera angles. So it's interesting.
Satya, this is a great time to talk about this episode's sponsor, OpenCV.ai Consulting, who is the team behind this new service called Copycat. That's KOPIKAT.co. I'm going to go ahead and share my screen here if you want to do a quick little talk about Copycat before we get on with our questions. You can take a look at the website here. It's KOPIKAT.co. There was a recent experiment with MS Coco. Would you like to talk to that a little bit, Satya?
Yeah, so this is this is an example of generative. We are calling it generative data augmentation, right? Now, as you know that in data augmentation, the idea is that you take existing data, and without changing the annotation or without having to annotate it again, you can create more data. And typically in data augmentation, you rotate the image, you scale the image, you crop the image. And because you know how you're rotating, cropping, or scaling the image, you can transfer your augmentation. Now, in case of copycat, we took the idea even further. Let's say you have this image on the left-hand side, the top left-hand corner. Let's say that's the input image. You upload it to copycat, and it produces, right now the interface is very simple. You basically upload one image and you provide your email address, and we create these variations of the scene under different conditions. It's a different car, it's a different environment, but the annotations are preserved, right?
It preserves your already labeled data, yes.
Yeah, so you can, if you put the images on top of each other, you will see that the annotations are perfectly preserved. The boundaries of the car don't change at all. The boundaries of the road doesn't change at all, but you can see that we created these different examples, in different scenarios, right? And no additional augmentation is necessary. And we did some experiments with COCO dataset. We took 5% of the COCO dataset, which is about 6,000 images, and we trained an object detector using that model, and then we also used these 5% images to augment, to create new images. And we could see, I think it was 14%.
Yes, 14.6%.
Yeah, so we saw 14.6% improvement in the map score.
And that was just with 5% of the images.
Right. So with 5% of the images, if you compare 5% of the images and 5% of the images plus augmented data, based on those 5% of the images, then we got a 14% improvement. So, and this is all free, right? I mean, if you think about it, this did not require any manual annotation, and it's kind of free. And the gains become less if you have a lot of data. Let's say if you used the entire COCO data set, then the gains would be, let's say, in the 1% range, right? But most of the time you do not have that level of data. You are never going to have that kind of data set. Usually your data set ranges, for most companies and most problems, you would get 5,000, 10,000, if you're lucky, that kind of data set. And using this augmentation technique is really awesome, in my opinion.
Yeah, and folks can go try this out for free by going to copycat.co. That's KOPIKAT.co. Tap the little upload button. You'll just drag and drop your image, type in your email address, and you'll get back 5 free augmented images to see if it'll work or how well it will work on your data set.
Right. And you can also go to pose.copycat.co, and it generates and upload an image of a human person, human with different pose, and you can get the same pose under different camera viewing angles, and everything about the photo changes except for the pose annotation. So that's something that you can try as well. It is less baked than the general one. It is still, we are still developing it, but copycat, the regular copycat where you don't change the camera angle, that is pretty solid right now.
Yeah, we went to did a bunch of live demos at Embedded Vision Summit. That was a lot of fun. Thanks to everybody who joined us at Embedded Vision Summit the other week. It was great to put some faces to names for a lot of folks that join us on the show. Now I think we should take this time to do our giveaway. Our generous guests have stated that they will be giving 1 year of SuperAnnotate to our trivia winner today, and a certain number of image upload credits as well. We really do appreciate that. So the way this works is I'm going to ask a trivia question that I have created based on the slides that our presenters gave today. You in the Zoom chat will have the opportunity to answer that question, and the first person to answer it correctly will win the sweet prize that I just described. Get ready to answer the question now in the Zoom chat. So earlier we saw this data set with 11 million images, and the original human time to annotate them was about 34 seconds. After AI assistance, how many seconds was it taking per image? Ooh, wow.
Ooh, that was fast.
Hokey smokes Bullwinkle. Looks on my screen, I see Toto Tall. The correct answer was 14 seconds. You were just Johnny on the spot there.
I see Toto as well.
Congratulations. Yeah, congratulations, Toto. Please send one email to phil@opencv.org, and we will get you your SuperAnnotate and credits, thanks to our generous guest today. We have got a whole bunch of questions from you all. This was apparently people were just really interested in this topic. I'm picking a few off the top to get started with. We've got a few minutes left, so let's answer some questions, huh? Mahmoud would like to know, we talked about different types of segmentation earlier in the show, and he would like, he said, sorry for the noob question. First of all, you don't have to apologize. Second of all, the question was, which segmentation is better when you're likely to have large changes in lighting intensity? Is there a reason why you would want to use like a certain type of segmentation based on the lighting, or is it really just something based on what you're trying to find? Thoughts?
Yeah, on my end, I don't really have an exact answer, and I don't really feel it's at all a noob question. This is a very, very technical question that I think even some people will write a paper, because just experimenting and seeing what kind of kernels are, if you're doing convolutional network, let's say, would really contribute to that. This sounds a very interesting question. So I don't really have an answer. Oscar, anything on your end, or Satya?
Not really. It's difficult because,
we got some more context here from our question asker. Mahmoud said it's a solar thermal application specifically.
Right. So what I feel is that the choice of whether you want instance segmentation versus semantic segmentation, that mainly depends on whether you care about the instance or not, right? Both of these methods, given the data, you can improve it to your desired level of accuracy, given assuming that you have enough data, right? So the more important question to ask here is whether you need instance segmentation at all or not, right? Many times you don't. And if you don't, then don't spend the extra time. Computationally, it is more heavy when you do instance segmentation, because so that's my answer. But it is still, as Mohan said, that it's a difficult question to answer, because whenever you have this kind of question, there is no generic answer to it. And it depends on how many iterations you go and how much careful you are in gathering data where it fails. So you can take a model and make it way better. But the only thing I would like to say, one other thing before I give Oscar a chance, is it's usually not the model, right? Once you have chosen, okay, I'm going to do semantic segmentation, right? There will be many different semantic segmentation architectures which more or less will perform the same, right? If you want to get that 0.5% improvement, then okay, that may be useful for changing the architecture. But let's say you are off by 5%. It's not the model that you have to worry about. You have to go and work on your data, either gathering the right kind of data or making your data annotation consistent, which has huge benefits. So instead of trying to experiment with model architecture, if you just go and see what instructions you had given, because usually in data annotation, you're having multiple people do the annotation, they must have done something differently. No matter how careful you are, if you're only using one iteration, then these people, no matter how careful they are, they would have understood the problem slightly differently. And you will see that there would be differences between people who annotate, and within the same person also, they may come back next day and their annotations would look different. So it is very important to go and check the data, have several rounds of iterations, and sometimes several rounds of instructions also. Sometimes it may not be clear, like in the shoe example, whether you keep the toes or you remove the toes, that has to be very explicitly mentioned, right? When you are giving this data annotation task. So spending time with the data is much more important than the exact architecture you chose, as long as you're picking something reasonable. Oscar?
I don't really have anything to add here. I think there are a lot of great great answers to that instead. So yeah, difficult problem you have to like good luck on trying to figure out a good solution.
Yeah, it sounds like somebody might have a paper for next year's CVPR, maybe.
And
Ellen,
the
go
good
ahead.
luck was said in the straight tone. It is not a sarcastic tone. Good luck on figuring
Good
out
luck.
the solution.
Good luck. Ellen would like to know, a couple people asked this question actually, but is there a way to, do you expose the segment anything options at all in SuperAnnotate for users that might have very specific needs? Like, for example, somebody was talking about segmenting grains of rice, for example. Is there anything like that that maybe they can tweak to based on the scale of the items they're trying to segment?
So the parameter set is fixed now, and we're doing a lot better with like larger items than if it's very, very smaller one, when it's like a teeny tiny rice in the kind of grain of rice. It's going to be tough to select, but in those cases, sometimes I think a better approach would be is like to select a few in your image and then go and do model assisting type of labeling, because all these different types of rices are so similar in the image that you would try to do this few shot learning type of approaches, in my opinion. Yeah.
Anything to add, Satya or Oscar, to that? No?
No, it's very difficult when you have small objects, that segmentation. I mean, the annotation itself is very difficult. And then if you want to segment it, it's even more difficult, even after you have good annotation.
Seth would like to know, had a question about generative data augmentation more broadly, I think. He says he'd like to know, is there a risk of say overfitting due to the position of items in the generated data?
Yes.
How could you maybe mitigate that, or just be careful as to not poison the well, so to speak?
Right. So there is a risk. That's a very good point. So in addition to this, once you have generated this this data set, you should also do traditional augmentation on top of it. So you scale it, you stretch it, you do a rotation, etc., and that should mitigate the risk quite a bit. But we have not done a very detailed study on that yet. But yes, you're 100% right that having the same objects at the same place, it can create unintended consequences.
And I would just like to, that's something that we also see in like real world data sets, right? You might have cameras taking the same type of images all the time. If that fits your end use case of the model, that's great. If it doesn't, that's a problem, right? I think usually on this data sets as well, like you see a distribution of where the masks are most commonly appearing, and that differs a lot between data sets. So that can be a good thing to kind of take into consideration on what your use case would be and what data sets you are using. But there is
we
general
always have to
middle images.
Right. So in machine learning, we always have to be very careful that the model is not memorizing. It's just like a student, right? If you give it easy questions, they will just memorize the answers and spit it out in the exam, and you would think that, oh, they're brilliant, without learning, right? So we have to make things harder for the model so that it doesn't memorize, but instead it learns. For example, if things are at the same place, like in an industrial setting where the camera doesn't move, it's exactly at the same setting, and all your data has come from this plant, but in a different plant, it's a different setting, right? So in that case, you have to be very careful. Otherwise, the model will learn that, oh, this location is more important than what's inside it. And that's something that you have to avoid. You should actively think about how to make it harder for the model to not memorize and to learn.
Sounds like it's, like everything, the answer is it depends. Yeah, we're about 5 minutes past the hour here. I think we can probably wrap it up. If you folks have more questions that before we get to that, if you folks have more questions that were not answered and you'd like to get your answer off the show, you can send an email to newsletter@opencv.org and we'll do our best to answer those questions there. Satya?
Yeah, so I have a question about how segmentation is.
I think we just lost your audio, Doc. Yeah,
You lost my audio?
Oh, you're back. You're back. Can you hear us?
I can hear you.
Okay, we can hear you now.
Okay. So one of the things that has happened in the last few months is computer vision used to be isolated, right? Everything used to be manually annotated. The computer vision models did not have a sense of what's inside the image until you tell it what's inside the image, right? But now things are changing because we tied computer vision models with NLP models, right? NLP model, they are trained on billions of tokens. And so they have an understanding of the world, so to speak, right? So because they are, trained on images and text associated with it, which is at internet scale, right? It is not the scale at which you're annotating, right? So now suddenly vision models have this intelligence which is coming from language models, right? So how does it change, the segmentation world where, we have already seen that, for example, SAM is able to segment, and then we just have to pick the right segments, usually, with some modifications. But are you seeing some massive changes coming to this segmentation world because of this combination of large language models affecting or helping vision models?
Yeah, I can jump in maybe there. I was mentioning earlier that few-shot learning was very much a research project a few years ago. Yeah. I think we're coming to a place where few-shot learning can be very, very beneficial within the annotation. So the way I see it is not really that much of a prompting, but I would rather see it like you select something and then you say that go and find something similar in the rest of the data set. Rather than kind of explaining. You can explain as well, but then explaining is as fast as like putting one bounding or box or do one click is going to be even faster. So I do see that those few-shot learning applications will come and they will be better and better, especially when we will have one truly foundational model in the industry, not really we didn't really have a truly foundational model in computer vision, I feel.
Right.
And I feel in some ways that if we are talking about NLP and computer vision together, is usually like auto-captioned images from internet in some ways where you're gathering that combination of them. So there is a lot of domains where that is not definitely applicable. So if we have, say, not just regular RGB imagery or other things as well, it might not translate as well as we want it to. So I think, as we see with some of the chat application, they don't always apply super well. Visually, testing it out, it works well, but when you come down to it, it doesn't always work too well. So I still think we'll have that for a while, at least in the classical way of doing it.
Right. And the few-shot example is really good. For example, how effective it is going to be. I'm just very excited about it. Like in case of stable diffusion, for example, you could take just a few images of yourself. Like I could take 20 images of myself and create an avatar of myself and put myself in different scenarios. And I have fooled my friends also with that, with those images. So they are getting very realistic. And you can imagine that you can do it for any kind of object, not just humans. Humans, it's easier in some sense because, there are so many pictures. I don't know, a very large percentage of pictures used to contain humans. I don't know whether it is still true. Now it may be food.
I would say food, dogs, and cats are probably overrepresented, like on a global scale, right? We know dogs are overrepresented in cocoa for sure. But yes.
Yeah. Anyways, so that's some very interesting things are going to come in very near future.
Yeah, definitely. So yeah, we're about 10 past the hour. Before we let you go here, before Satya takes us home, I'd just like to remind everybody that OpenCV is a nonprofit. We run on your donations and our partner organizations. You can support OpenCV directly by going to github.com/sponsors/OpenCV and do a monthly recurring donation or a one-time tip to the team. We really do appreciate it. Go check that out. And if you've got a couple extra bucks, send them our way. If you liked this episode, if you didn't like the episode, leave a comment in the comments section. Let us know. We will be back next week at the same bat time, same bat channel, 9 a.m. Thursday. Any last words for our episode today, Satya?
No, that's it. Thank you so much, Vahan and Oscar. This was a very interesting conversation we had today. And thank you, Phil. And as always, thanks our audience for being with us and supporting us. Thank you.
Yes, absolutely. This is OpenCV wishing you a great day wherever you may be.
All right. Bye.
Bye.